Welcome to Radiation Oncology course. I am Dr. Ganesh Kumar Patel and this is the lecture number 35, Radiation Safety Part 5. So in this lecture we are going to deal with the various kind of radiation safety interlocks, the radiation safety installations, the requirement of a radiation safety installations and the radiation emergencies. In radiation safety interlock, generally there are three types of radiation safety interlock. The radiation warning lamps, you can look at the picture. These are the radiation warning lamps, which is like a day-to-day life local traffic signals, in which there are three colors: green, yellow and red. So radiation warning lamps, what is the purpose of a radiation warning lamps? Radiation warning lamp purpose is to alert the radiation worker or the general public that when the radiation is on, the person should not enter into the bunker so that he will not receive any unnecessary exposure. This radiation warning lamps is generally placed over the entry door of a bunker, and it should be clearly visible. And there are three colors. The red colors indicates that the beam is on or radiation is on or radioactive source is out of the safe. Then yellow state indicates that the radiation is in a preparatory mode. In case of telecobalt, the source is ready to come out of the shielding to the active position of exposure. In case of linear accelerator, the machine is ready to deliver the X-rays. And green indicates that the radioactive source is in the shielding, and in a safe. And in linear accelerator, the X-rays are not being produced. It is in off condition, like a switch on off situation. So this is the purpose of a radiation warning lamps. Then the next interlock is the door interlock. This is the additional safety interlock. So why door interlock is required? If the person who is in special radiotherapy technology is going inside to perform a setup of a patient, and one person is coming out of the bunker, and he forget that some other person is remaining inside, or he is on the way to come out and he started the machine. So there also possibility that some amount of radiation being exposed by the second person who is just on the way of coming out. So this door interlock, what happened? Door interlock don't allow the person to switch on the machine because a door has not been closed. So once the door is being closed, the interlock circuit is complete and machine can ready to beam on. So this is the door interlock. It's a simple switch which is just fixed on a door. And third is the last man out switch. This is the additional safety which is the Atomic Energy Regulatory Board accepted in 2017. In this case, some accidents have been happened that the last man who has to come out of the bunker, before he come out of the bunker, the person who reached on the console started to deliver, means he has just closed the door, and he forget that the second person is still in the bunker and switched on the beam. So such accidents happen that person gets exposed to radiation. So to avoid such a situations or to prevent such an accident, ARB introduced a last man out switch. In such a case, the person who is coming at last from the bunker, he has to press one button, which you can see here. This is the picture of a last man switch. He will press the button. Once he press the button, the circuit will be closed, and then only the machine can ready to switch on the beam. All these three interlocks are interconnected interlocks with the console of a machine or integrated with the electronic circuits of a machine. It means that if any of the interlock is failed, then machine will not allow you to deliver a radiation unless it has not been override. Now I will show you where these interlocks has been placed in a radiation bunker. So if this is a bunker, you can see this is a primary barrier, this is a primary barrier, this is the isocenter position, this is the machine. Here generally we can put a last man out switch, or you can put a last man out switch here also. or here also you can put last man out switch. Then your door interlocked is placed over the door, and your radiation warning lamps is placed over here. So in this way these three interlocks are being placed in the radiation bunker. So besides this bunker, there is a one more safety, I cannot say a safety interlock, but it's a emergency situation, but emergency switch which helps to prevent any accident during the treatment of a patient. So this there are several emergency switches switches is being placed in a machine and in a bunker, and these are the requirement from a regulatory body of a manufacturer. So there are multiple emergency switches, like there are two emergency switches on a couch, there are emergency switch on a machine here and here, then emergency switch here, then emergency switch here, then emergency switch here, emergency switch is here, then emergency switch on a console. So it prevents any accidental condition. Okay, now we are going to understand the radiotherapy installation. So you have seen that these are the radiation bunker. So for starting a radiotherapy center, we need to get approved a site layout from the competent authority, which is the Atomic Energy Regulatory Board. Before getting approved from a regulatory body, there are certain conditions which needs to be followed for designing a radiation bunker. For what are the certain conditions? These are the certain conditions that workload, use factor, distance, occupancy factor, and barrier thickness. According to this factor, the barrier thickness is being calculated. So in radiotherapy installations, you need to according to the workload, suppose you are going to treat 70 patients per day or 100 patients per day. According to your workload, your bunker construction or the design of a bunker, depends. Then what is a use factor? Use factor is a fraction of a beam on time directed towards the particular barrier, and for primary barrier it is 1, and for secondary barrier it ranges from half to 1/4. Then there is one occupancy factor, because the outside the bunker, what are the occupancy? You can see in this picture. This is a picture of a 6 MV linear accelerator bunker, and what are the occupancy here? What are the occupancy here? What are the occupancy here? According to the occupancy, the shielding barrier thickness being calculated. Shielding barrier thickness is calculated, and how the occupancy is defined. So according to NCRP, we generally follow the NCRP. Offices, reception areas, laboratories, children's play area, nursing stations considered as a full occupancy, and their occupancy factor is 1. Then ward, patient rooms is also considered as a full occupancy, and their occupancy factor is 1. Then patient examination and treatment rooms or corridors as considered as a partial occupancy, and their occupancy factor is 1/4. Toilet, bathrooms, outside areas are considered as also partial occupancy factor, and their factor is 1/16. Stairways, unattended waiting rooms also considered with 1/16 occupancy factor. So when you calculate this workload, use factor, and occupancy factor, you need to put all these values in the formula of a barrier thickness, that is WUT, and P is the permissible dose limit of a radiation worker and a public, into D is a distance square. So for calculating the barrier thickness, you must know the workload, the occupancy factor, then use factor. Use factor, I said you that for the time for which, fraction of time for which gantry faces the primary barrier. Okay, so for primary barrier it is 1, for secondary barrier it is half. So considering all these factors, after putting into the formula, you can calculate the barrier thickness of a primary. This is a secondary barrier, this is a secondary barrier, and this is a primary barrier. These are the sections, X, Y and Z sections, because when you want to submit a layout to the ARB, you need to provide the sections of a layout X, Y and Z. and after ARB will assess, evaluate all your as per the conditions, criteria of your requirement, and approve the site layout. And once it has been approved by the competent authority ARB, then only a radiation facility can go for construction. Now we are going to deal with the radiation emergencies. First we will understand what is meant by radiation emergencies. Radiation emergency is the emergency condition where there is a possibility that the person being exposed to radiation, unwanted exposure to a radiation worker or a public because of malfunctioning of an equipment or any kind of negligence. So here there are radiation emergencies we are going to discuss related with telecobalt and brachytherapy. So in case of telegamma sources slip down from the source head. So this is a very critical radiation emergency, and it has been happened in many cases that when radioactive source, cobalt source, is coming out of the shielding to the on position, it has been because of the spring action, because malfunction of the spring, the source not moving back to the shielding, and instead of going back to the shielding, it has fallen on the ground or the bottom of a machine. So this is the biggest emergency in case of a telecobalt machine. Source fails to return to the off position after treatment. So in this case, source is stuck in between the on position to off position. It is still out of the shielding condition. Timer malfunction causing overexposure. Your timing, the timer which is available on console is malfunctioning. It is not giving you the exact time of exposure. Treatment with incorrectly mounted or wrong accessories means you want this is generally happened. Instead of putting a 15-degree wedge, you inserted a 20-degree wedge, or the orientation of wedge was wrong. Treatment without the intended accessories, same thing is that overdoses due to the calibration errors, setup errors, or operator errors. So these errors is generally happen because of the wrong calibration or the wrong dosimetry. And in case, what are the brachytherapy emergency situations? Source fails to return to the off position after the treatment. The same thing is that once the source exposed to the patient, it has to come back to the shielding, but it has not happened. Source stuck in the applicator, or because of any kink in a applicator. The source can be broken loose from the guide wire and can remain inside the patient body. This is also a big emergency, that source is remained in the patient body, and error in entering the reference source strength into the treatment planning system can lead to the accident. So this is again the dosimetrical issue. The actual source strength is different and the entered source strength is different. So it will create a wrong calculations, wrong treatment time, incorrect patient dose calculation, especially for the manual brachytherapy. So for handling such an emergency, the competent authority came up with the solution that every radiotherapy installation should prepare a emergency preparedness plan, in which the step-by-step process of handling such a radiation emergency will be explained in thorough detail. So this is as per the rule 33 of Atomic Energy Radiation Protection RPR 2004 Act, with chapter number 7. Emergency response plan should be prepared. Objective of emergency planning is to mitigate radiological consequences of accident and minimize the normal and potential exposure to worker, members of the public, and the environment. The RSO, that is Radiological Safety Officer, should assist the employer licensee in developing the suitable emergency response plans to deal with such an accident. Now, how telecobalt emergency procedure like a source stuck, which frequently happen in telecobalt machines, the source stuck. So how to handle such an emergency situation? So this emergency situation has to be pasted. Handling of the emergency situation has to be pasted on the telecobalt machine. Radiation worker can see that emergency chart, and he can follow that chart to avoid such an emergency. So what happened? First, press the emergency stop button if source is stuck. Then turn off the power key and switch on power again if source does not go to the off position. So if you follow this step on and off, still source is not in off position, then remove the patient from the treatment room, immediately inform to radiological safety officer. Rotate the gantry such that the primary faces away from the maze area. So you have to rotate the gantry like this, and it should face like this. And then enter the treatment room wearing a TLD badge. It is very mandatory, with pocket dosimeter, carrying a survey meter. So you must have a TLD pocket dosimeter. I explained you the pocket dosimeter give the immediate response, immediate radiation level, and a survey meter. Then T-rod is the device which are used to pull back the source which is out of the shape back to the safe position. With the T-rod, push the drawer firmly. You can see that the person, in his hand there is a T-rod. The source goes to the off position. Push the drawer firmly such that source goes to the off position. For rotating wheel, turn the wheel in a direction located, source goes to the off position. Inform the service engineer. So this is a T-rod. You can see that this is a T-rod. This is the area. Once you push the source, it should not cross this line, means beyond. You cannot push much force. If you push with much force, there is a possibility that source, instead of going back to the safe position, will go down in the machine. So you have to take care while pushing this with the T-rod. Then in brachytherapy emergency situation, this is the internal, once you remove the cover from the brachytherapy unit, you can see that it looks like this. Here there is a active source, this is active source and a dummy source. So I want to tell you that in a brachytherapy machine there are two sources. One is a dummy source and one is a active source. So what happened, dummy source first go to the pre-plant position, which is according to the plant, and verify that is there any obstruction is not there. If there is any obstruction, it will not allow you the active source to go to that position unless you correct that mistake. So dummy source is very important, and it is there in the brachytherapy unit. Emergency stop button, hand crank. Hand crank is there if remotely source is not going to the safe position, means by automatically it is not going back to position, then you have to manually retract the source with the help of hand crank. Here there is a hand crank. Then here the channels are there where you have to insert your applicator, transfer tubes through transfer tube, and this is the diagram of your machine. Here it is a stepping motor because the brachytherapy source is a stepping deliver dose through steps. In case the source does not go to the off position, this is the emergency. It's a source stuck. In such a case, source does not return back into the brachytherapy unit. Press the interrupt button. The next step is the press the interrupt button or the emergency stop button. This is the common step in both telecobalt and brachytherapy. In case it does not go off position, use the hand crank, I said you that, and manually retract the source to off position. While entering the treatment door, wear the TLD, pocket dosimeter, and carry a survey meter to know the radiation level. If it fails, remove the applicator using a long handle forceps. So even if with the hand crank you are unable to retract the source, in such a situation you have to use a long handheld forceps and cut the source, means those source wire. You have to cut the source wire and with the handle forceps take the source and put into the lead container. If unable to remove applicator, cut the source, which I said. At every monitor the radiation level in the room and patient monitor prior to release. Now the typical emergencies in linear accelerator. So there are also emergencies happen in a linear accelerator even though there is a no radioactive source. So generation of radiation fails to terminate after intended time of period. So this situation occurs when your monitor chamber is failed, because in linear accelerator there are two chambers which we call monitor chambers, first chamber and then there is a backup chamber. So what happened, if your plant MUs has been over and even though your machine is keep on exposing X-rays, it means that there is some problem with your monitor chamber. In such a case, you have to press immediately the emergency stop button. An accelerator is unintentionally energized, so this is also emergency. A safety system or a warning system malfunctions, including deliberate action to override a system. So this is happened. What happened in if your movement of a couch suddenly keep on rising, means either vertical, horizontal or lateral, and it is you're out of your control, means even though you have a hand pendant in your hand and you are trying to control, even though your action is not allowing the couch to control within limits, then it can ultimately damage the patient's because there is patient is lying over the couch. Another malfunction causes X-rays to be generated other than the controlled manner. Physical damage cause the effects of shielding or filtration. So suppose gantry is hit with the couch and the shielding of a head has been damaged, so there is a possibility that leakage radiation will increase and it will expose more radiation to the surrounding person or person who is handling. Access for changing the treatment parameters to unauthorized people. Some unauthorized persons is accessing the machine. This is also emergency. And one of the biggest emergency is the lost source. Major concern for radiation protection. So in radiotherapy facility, loss of source is possible due to the discharge of patients with temporary implants not completely removed. So this is generally happened in past, that patient being treated with a manual brachytherapy sources, and doctors have forgotten, or medical physicists forgotten to take out the source from the patient's body, and source remain in the patient body and patient have been discharged. So and because of this is a critical situation for the patient as well as the attender or the family person who is with the patient. So this is a big emergency. In theater, during implant of a radioactive seed, so you implanted the radioactive seed and you forget to track the radioactive seed. During brachytherapy treatment, all radiation facilities should establish an emergency plan to deal with accident or loss of source and ensuring the proper emergency preparedness plan. So this all procedures should be mentioned in your emergency preparedness plan. The patient who have undergone brachytherapy and also all equipment, clothing, linen and waste going out of the brachytherapy department as well as radiation ward shall be monitored appropriately to ensure neither loss of source nor contamination. So this is the precaution which needs to be taken. The person those are working in a brachytherapy department should keep close watch on the equipment, clothing and linen or radioactive waste going out of the brachytherapy. It should be scrutinized before going out of the brachytherapy department. Such emergencies most generally happens in a nuclear medicine department more, because there are the liquid sources handles, and thus radiation safety is more concerned in nuclear medicine department. As per ARB safety code, in case of loss of source, immediately the employer or radiation safety officer should report to the competent authority within the 24 hours of the accident or loss of source, lodge a written complaint with the police in case of loss or theft of radioactive source, and if they are not traced within 24 hours. So this is the immediate action needs to be performed. Now we must understand the radiation dose limits for a public and for a radiation worker. So the radiation dose limit for a public is a 1 millisievert in a year. Radiation worker or occupational exposure is 20 millisievert per year, averaged over 5 consecutive years, and an effective dose of 30 millisievert in a single year is acceptable. This is the effective dose. Equivalent dose for the extremities, for the lens of a eye, it should be 150 millisievert in a year for a occupational exposure or radiation worker, 15 millisievert for a public. For skin it is 500 millisievert, for public 50 millisievert, for extremities like hands and feet 500 millisievert for a radiation worker, and there is no limit because the public is not handling. For a pregnant radiation worker, after declaration of pregnancy, equivalent dose limit to the embryo or fetus shall be 1 millisievert from the remainder pregnancy period. This is the important line. Equivalent dose limit to embryo fetus shall be 1 millisievert for remainder period of pregnancy, means after declaration of pregnancy. So these are the dose limits for radiation worker as well as public. Now the investigation level of excessive exposure. So these are the common things which also happen in radiotherapy or any radiation facility of overexposure. So what happened in overexposure? If the dose received by radiation worker in a monitoring period is a 3 months quarterly monitoring period, exceeds 10 millisievert, then it is considered to be investigation level for excessive exposure. So if any radiation worker is receiving a dose of greater than or equal to 10 millisievert per quarter, then it will come under the investigation for excessive exposure. If the dose received by any exceed these limits, the employer shall provide alternative work not involving radiation to the exposed person till further instruction obtained from the ARB. The RSO should carry out prompt investigation on causes of increased level of. So RSO should need to investigate how this has happened, what kind of practice he failed to deliver, with safe practice he failed to deliver, and he received such an excessive exposure. So an investigation report has to be submitted to the ARB. Then there is a overexposure limit for annum is greater than or equal to 30 millisievert. For a block of 5 years, it is greater than 100 greater than or equal to 100 millisievert per year. Now ARB regulation and act. ARB, there are structure and legal framework of ARB is that Atomic Energy Act in 1962 passed by the Parliament of India. Its principal requirement and regulation is the Radiation Protection Act RPR 2004. The purpose is to, this act has to create the standard codes of practice, safety guide, manual. These are all the responsibilities of this act 2000 RPR Radiation Protect Act 2004. So structure of legal framework. Atomic Energy Regulatory Board is constituted in 1983 and it is national regulatory authority. Chairman ARB is the competent authority, which I earlier said. To obtain a license of a radiation facility, the rule number 3 allowed the conditions of issuance of license. Rule number 7 explain the conditions of license, and rule number 3 provides the license of radiation facility. And rule number 19 of Atomic Energy Radiation Protection 2004 Act allow the designation of a radiological safety officer. What are the responsibility of radiological safety officer? This is the responsibility defined under rule number 22 of the RPR 2004 Act. Carry out routine measurements, maintain record, investigate situation for potential exposures, report on hazardous situations, emergency, quality assurance, advise, assist and employer licensee for adherence to the terms and conditions, safe handling and disposal of radioactive material, routine measurement and maintenance of training of radiation worker, radiation hazard and safe practice, modifications in working conditions for a pregnant woman. These are the some responsibilities of RSO. And major consenting process of radiation facility is you can see through this tree diagram. Regulatory process, first is the licensing step, then layout approval, then RSO approval, permission for procurement of a equipment of radiation generating equipment, then commissioning, license of operation, replacement or disposal of disused stores, decommissioning, transport, and the other part of regulatory body is the regulatory inspection and enforcement. Now Atomic Energy Regulatory Board has introduced in 2013 the online mode of radiation application that is being defined as e-LORA, e-licensing of radiation application. This has saved the time of a regulatory process, and it has given a registration process of a radiation worker, and these it looks like this. You can see that when you type on a Google, the Elora process looks, Elora licensing site looks like this. Here an individual can register himself in as a radiation professional, and any new institute has to register with this institute. Here you can obtain your username and password once you submit your documents. Here you can see that the process of institute registration, process of radiation professional. Here you can also see that your application status and guidelines. You can see that here are the guidelines for radiation facility and other departmental facility, well explained in the guidelines. So these applications, Elora has simplified many of the things and decreased the time of regulatory process and saved a lot of time for the institute and the radiation worker for the safe practice. Thank you very much.